Hello everyone, so today we have another medium problems course after flipping matrix. So in this question we are given a binary matrix, grid, and one move consists of choosing any row and column toggling each value in that row or column. That is, either we can select a row or a column and we have to flip all of its entries. So if we select this row, we need to change it to 1. Let's use some other color like orange. Okay, so that would be 1. That would also be 1. Now 1 will be flipped to 0 and that will be 0 again. Similarly, if we choose a column, all of its entries will also be flipped. So for this column, this will be flipped to 1, 1 and 0. And every row of the matrix interprets a binary number and the score of the matrix is sum of all these numbers. So if we look at the current matrix, how we can calculate the score of the matrix is by considering each row as a binary number. So the first row, first let's write the binary digits. So here it will be 2 to the power 0, 2 to the power 1, 2 to the power 2 and 2 to the power 3. So the first number would be 1 plus 2 and the second number would be this 8 plus 2 and rest is 0. The third number will be 8, 4 and rest are 0. So we don't need to write them. So the numbers that we'll get are 3, 10 and 12. So if we add these three numbers that we are getting from each row, that would be our score. So currently our score would be 25. And we can perform any number of these operations, that is selecting a row or a column and flipping its entries. We want to find out the maximum score possible by doing these operations. So how can we do that? Let's take a closer look to this matrix in the next slide. If we just want to maximize a binary number by flipping its entries, so if we see this example, or let's say any other string, any other random string, let it be 0, 1, 1, 2, or not 2, it's binary string, sorry. So this will, if we flipped it, it will be 1, 0, 0 and 1. And one thing that you should have noticed that this first digit is now flipped to 1. This is nothing but the MSB. Why we are giving this first digit so much of attention? Because if we look at any binary number, so its representation would be like power 0 to the power 1 to the power 2, and let them be any 0, 1 or anything. And let's say we have the first digit at, let's say here it's 3, 4 and 5. If you add these number, what you are going to get? I'm saying if, let's assume these all are ones, but this first digit is 0. If that's the case, then the sum of this will be 1 plus 2 plus 4 plus 8 and 16. So this will give you 16, this will be 12, this will be 3, 16 plus 12, 28, and you're going to get 31. But if you just look at this number 2 to the power 5, it is going to be 32. So the first MSB is alone greater than the sum of all previous bits, even if they are 1, and they all might not be 1, but still if this is 0 and we flip this, if we flip this, we will get the MSB as 1 and rest all zeros. So we are getting the maximum number if the MSB is 1. And if we look at this example in this row, this MSB is 0. So what should we do? Of course we should flip it, because we are going to get the maximum number if the first digit is 1. Because if it's not, then all of these, if they are 1 or not, they will be lesser than the MSB. So we need to flip this row. And not only this row, for any row in the matrix, if we find that the first element of the row, those are these elements, if they are 0, we need to flip the complete row. Because if we flip the complete row, we will ensure that this first MSB is flipped to 1, and we cannot do this with column, because flip this column, then these ones will become 0, and we don't want that. So how would our matrix look now? The first row will be flipped, so that will be 1, 1, 0, 0. Then all the others row right now will be same because they had their MSB 1 only, so we don't flip them. And now let's talk about columns. As we have fixed the MSBs to be 1, and now we won't alter the rows, because if now we flip any of the row, then what is going to happen is that you are going to flip the MSB also, and we know that that won't give us the maximum score. So now we move on to the columns. And which columns do you think we should flip? Of course, not this column because it has all ones. We have ensured that because these are MSBs. So those will be ones. And now which column do you think we should flip? We should flip only those columns now which have greater number of zeros than 1. And what do I mean by that is this column and this column. And why is that? Because these zeros will be flipped to 1 and we are only flipping those columns which has more number of zeros. So after flipping, we will have more number of ones. And that will give us the maximum ones in those columns. And so we need to flip this column and this column, because if we flip this column, then we will have 0, 1 and 0. And we will lose 2 of our 2 to the power 2. Don't forget that these are binary. So this will be 2 to the power 0, 2 to the power 1, 2 to the power 2. And what we are doing here is we are selecting this column. And when we select this, we will lose 2 of this 2 to the power 2. And so we won't do that. But here, the case is reverse. We need to flip it because there are 2 zeros. So we will flip this. So that will be 1, 0 and 1. And that will be our maximum column. And this column, that is to be flipped. And it should be flipped to 1, 1 and 1. So our final answer would be 1, 1, 1. And we won't flip this column. And then this column needs to be flipped. 1, 0, 1. And definitely the last column will also be flipped. So what is the answer that you are going to get is, you will convert this now to score. So till now, the coding part of this problem is really simple. I will leave it to you. But what you need to do is first flip the rows of the matrix such that its MSB should always be 1. And then move on to the columns, and while looking at each column, count the number of zeros. If the number of zeros are more than number of ones, then you definitely need to flip the column. And so you will have 2 functions, flip row and flip column. And a third function may be to calculate the score of the matrix. Now let's calculate the score for this matrix. 3 to the power 2 to the power 1 and to the power 0. So let's calculate score for this matrix. That will be this 3 plus this 2 and 2, 4 and 4 and 4, 8 and then 24, because this will be 8. Now if you add them, you can also add them like column wise, converting this row to the equivalent decimal number and then adding these decimal number, but this will also work here. And now you will get the answer as 39. And that's the optimal answer for this test case. So I hope that you have understood this video. If you have a better solution to this problem, feel free to comment down. Goodbye.